Hi everyone. In this video, we're going to be talking about dilution. So what do we mean by the term dilution? Well, to dilute something means to make it less concentrated. So if I had a solution here with this many particles in solution and I add water, the volume gets bigger, but I didn't add any solute particles. So the same number of particles that were in here originally are the same number of particles that are in this solution. All we did is just add more solvent to make it less concentrated, so the particles are further apart. This would be a concentrated solution. This would be a diluted solution. Now, we have an equation here. C1V1 equals C2V2. And this is going to be the equation that we use for diluting. 1 means initial, 2 stands for the final or the diluted. And so C is concentration, V is volume. Initial concentration times initial volume equals final concentration times final volume. And we can use this equation to make predictions about final volume or final concentration, depending. Let's do some examples. What is the final concentration when 0.5 liters of 6 molar hydrochloric acid solution is diluted to a final volume of 1 liter? So we're going to use our equation. C1V1 equals C2V2. The initial concentration here is 6 molar. The initial volume was 0.50 liters, and that's equal to the final concentration, which we don't know. That's what it's asking us. What is the final concentration? And the final volume is 1.0 liters. So we got to solve for C2. So if I divide both sides of the equation by 1.0 liters, liters cancels liters, we're left with molarity, which makes sense because we're solving for concentration, and I should get 3.0 molar as C2. And looks like we did it right. Let's do another one. What volume of a 2% M over V HCl solution can be prepared by diluting 25 milliliters of a 14% solution? Well, we're going to use the same equation, C1V1 equals C2V2. The initial concentration was 14%. The initial volume was 25 milliliters. The final concentration is 2%. And the final volume is what we are trying to figure out. So to solve for V2, just divide both sides by the 2%. That cancels, and percent cancels percent. And so 14 divided by 2 times 25 should be 175 milliliters. And let's see if we did it right. Cool. Let's do another one. What is the percent of a solution prepared by diluting 10 milliliters of 9% NaOH to 60 milliliters? Same equation, C1V1 equals C2V2. And we are diluting 10 milliliters of 9%. So the initial concentration is 9%. The initial volume is 10 milliliters. The final concentration is what we're trying to figure out, so C2. And the final volume is 60 milliliters. Well, we got to get C2 alone. So I'm going to divide both sides by 60 milliliters. That's going to cancel. Milliliters cancels on this side. So we have 9% times 10 divided by 60. Can't do that one in my head. So 90 divided by 60, 1.5%. All right. Let's see if we did it right. Looks like we did. All right, last practice problem. What is the molarity of a solution prepared by diluting 0.180 liters of 0.6 molar HNO3 to 0.540 liters? Anytime you see diluting in the word problem, you know you're going to be using this equation. So that's the key word. If you see diluting, just immediately grab that equation. So the initial concentration here is 0.6 molar. The initial volume is 0.18 liters. The final concentration, we don't know. And the final volume is 0.54 liters. Got to get C2 by itself. So I'm going to divide both sides by 0.54 liters. That cancels. Liter cancels liter. So 0.6 times 0.18 divided by 0.54. I get 0.2 molar. It looks like we did it right. So once again, anytime you're doing a dilution, you see the word dilute in the word problem, use this equation. Thanks for watching. See you in the next video.